We want to do some algebra with functions right now, and you'll see I've written over on the board 3 functions, and what we're going to do is look at their sum, difference, product, and quotient, or at least some of those things. Let's look at our first problem. I've written over here f of x is 3x minus 5, that's one function. The function g is g of x equal x minus 2, and the function h of x is 3x squared minus 11x plus 10. So let's find a new function here, f plus g of x. Well, the definition for the sum of two functions is just their sum, f of x plus g of x. So I'll go up and write down f of x, which is 3x minus 5, plus I'm going to add to that g of x, which is x minus 2. So that's just some simple algebra. Now I'll combine similar terms, and I'll end up with 4x minus 7. So this is a new function called the sum of the functions f and g. F plus g of x turns out to be 4x minus 7. So when we add functions, we do it just like we think we would do. We just simply add them. Let's look at another one. Here I have the quotient of two functions, h over g of x. So I want to see what that's going to come out to be. So the definition for the quotient of two functions is going to be just their quotient, h of x over g of x. Now I'll go up to my list and I'll write down h of x, which is 3x squared minus 11x plus 10. And that's all over g of x, which is x minus 2. So here's my new function. I want to just see if I can simplify it a little bit. Let's take a look and see. It would only matter if there was a factor of x minus 2 in the numerator. So let's see if that numerator factors. X minus 2 times, what would it be, 3x minus 5. Let's just see, negative 6 and negative 5 is going to be negative 11. First term is 3x squared. Last term is positive 10, so that does work. Here's my denominator. I have a rational expression here which I can reduce to lowest terms, and I end up with just 3x minus 5. So 3x minus 5 is the quotient of the two functions h and g. So h of x over g of x comes out to be 3x minus 5. Let's look at another problem. I have the product of two functions, f and g, and I want to evaluate them at 3. So f times g of 3 is going to be f of 3 times g of 3. So I'll go back up to my original definition for the functions. F of x is 3x minus 5, so 3 times 3 minus 5. And then g of x is x minus 2, so that will just be 3 minus 2. So I end up with 9 subtract 5, which is going to be 4, times 3 subtract 2, which is 1. So that just comes out to be 4. So here I have the product of two functions, and I wanted to evaluate them at 3. I just take each one of them, evaluate them at 3, and multiply the two results together. I come out with 4, and that is f times g of 3. Next thing I want to look at is called composition of functions, and it's another way in which to combine functions other than add, subtract, multiply, and divide. Let's take a look. Suppose we have f of x is x squared plus 3x. G of x is 4x minus 1. Let's find the composition of f with g. That's what this little round, this little O right here stands for, is the composition of f and g. F composed with g of 0. The definition for that is that this means f of g of 0. So we want to evaluate the function g when x is 0, then take what we get and evaluate the function f there. So I'll start by finding g of 0. So when I substitute in 0 for x in the formula for g, I get 4 times 0, which is 0, minus 1, which is minus 1. So g of 0 is minus 1. Now I'll find f of that. That's going to be minus 1 squared plus 3 times negative 1. So that will be 1 minus 3, which is going to be negative 2. So the composition of f and g of 0 turns out to be negative 2. And by definition, what this means is f of g of 0. Let's reverse it and look at it the other way. G of f of 0. So that's g composed with f of 0, which is going to be g of f of 0, And so I'll find f of 0 by taking 0 and substituting in the formula for f. That comes out to be 0 squared plus 3 times 0, which is just 0. So I get g of 0, because f of 0 is 0. G of 0 turns out to be, just like it was the previous time, -1. So you can see in general, addition and multiplication with functions would be commutative. That is, f plus g would be the same as g plus f. But with composition of functions, it's not necessarily commutative, as you can see right here. F composed with g of 0 is a different number than g composed with f. So if I change the order in my composition of functions, I may change the result right here. So it's not commutative. Let's look at the next one. F composed with g of x. Let's find this new function, which is the composition of f with g. So I'm going to write this as f of g of x. Now my formula for g of x is 4x minus 1, so I want f of 4x minus 1. Now what f does to x is squares it and adds 3 to it. So this is going to be 4x minus 1 squared plus 3 times 4x minus 1. So I'm not going to take it any farther than that. I just want to leave it in this form right here. If you were doing this on your homework, you want to go ahead and simplify this. Multiply this out, 4x minus 1 times 4x minus 1 plus 3 times 4x minus 1, then combine similar terms. But I'm about to run out of room here, so I'm just going to leave it there. You can finish this problem. Let's look at the next one. G composed with f of x. Okay, that's going to be g of f of x, which will be g of f of x was given as x squared plus 3x. Well, what g does to anything is multiplies it by 4 and subtracts 1. So this is going to be 4 times x squared plus 3x minus 1, because that's the definition for the function g. Whatever's in the parentheses, we multiply it by 4 and subtract 1. So I can finish this one. This will be 4x squared plus 12x minus 1. So there is g composed with f of x. So the composition of g composed with f of x turns out to be this new function right here. So composition of functions is a little different. It's not addition, not subtraction, not multiplication, not division. It's a new rule for how we combine functions under composition. G composed with f of x is g of f of x.